In this very short video, we will look into 3 Chapter 24 exercises. As with other videos, you can pause the video after you see the question, answer the question on your own, and then compare that with my answer. First question, which of the following is a suitable starting material for preparation of a polymer? Polymers could be addition or condensation polymers. And for addition polymer, we need a multiple bond, carbon-carbon double or carbon-carbon triple bond. None of these compounds have such structural element, carbon-carbon double or triple bond, so this must be starting material for preparation of a condensation polymer. In that case, we need a bifunctional compound that has 2 functional groups, and both functional groups have to be able to react to form a chain, to form structural element that could be part of a chain. In case of compound A, we have keto acid, and that's not suitable starting material. We would need something like hydroxy acid that could form ester group, and then ester group could be part of the chain. B is hydroxyaldehyde, that's also not suitable starting material, but C is suitable starting material. C is material that could be polymerized into a polyester because it's hydroxy acid. And so we can polymerize that. We have 2 functional groups, so carboxyl group of one molecule of hydroxy acid could react with hydroxy group of another, form ester group, and then that dimer could react with another, and by formation of additional ester groups, polymer would form. D could conceivably form a polymer, but not on its own, because it's dibromide. And of course, 2 carbon-bromine bonds cannot react with each other from 2 molecules of 1,5-dibromopentane. They cannot couple with each other to form a polymer. Dibromide could react with something else, conceivably with some other organometallic compound, for example, let's say organocopper compound, to form a bond, let's say carbon-carbon bond, but that would require another component to form a polymer. On its own, it cannot form a polymer. So on its own, only polymerization of compound C would form a polymer, and that would be polyester. Question number 2. Which of the following pairs includes both a cross-linking reagent for an addition polymerization and a cross-linking reagent for a condensation polymerization? If you consider A, there is no cross-linking agent for addition polymerization. Phenyl group is not cross-linking agent. On the right, we have tricarboxylic acid, and that could be cross-linking reagent for condensation polymerization. But first one is missing, so A is not correct. B, we have 2 double bonds in compound on the left. So that is cross-linking reagent for addition polymerization. But we have then dicarboxylic acid, and that's not cross-linking reagent for condensation polymerization. We would need another carboxyl group. So, and the double bond in this case doesn't count, because double bond in that dicarboxylic acid will not cause cross-linking of a polyester, for example. C, same as before. On the left, we have cross-linking reagent for addition polymerization, but C is not cross-linking reagent for condensation polymerization. Again, double bond will not cause polyester to cross-link. And finally, D is correct answer. We have a compound on the left that has 2 double bonds. It's diene. So it's cross-linking reagent for addition polymerization. Each double bond can get incorporated in one of the chains of addition polymer and cross-link them. And tricarboxylic acid could cross-link, could be incorporated in such a way that it cross-links 2 chains, or at least causes branching, and then with more extensive branching, eventually cross-linking will occur. So D is correct answer. Question number 3. What is the structure of nylon 6? So you have to recognize nylon 6. Nylon 6 is an indication that it's formed, that nylon is formed from amino acid. So from a single component, not two components, let's say dicarboxylic acid and diamine, then we would have two numbers like nylon 6,6. First one, actually answer A, is nylon 6,6 because it's formed from 6-carbon dicarboxylic acid and diamine that had 6 carbons. B is amino acid, and that amino acid has 5 carbons. So B is nylon 5. C is nylon 6,6. It was formed from monomer that was amino acid that contained 6 carbons. D is obviously not correct answer. That's structure of Kevlar. Another type of nylon, a specific type of nylon, so that's Kevlar. So correct answer in this case is C. And this completes chapter 24 exercises.